Okay, this is the 2008 question 7 exam. A galvanic cell is constructed from the following two half cells under standard conditions. Standard conditions 1 molar, 25 degrees and 1 atmosphere. You've got a half cell with a nickel electrode and a solution of nickel nitrate and cadmium in a solution of cadmium. Given that the reduction potential of cadmium is -4, sketch on the above graph the direction in which the electrons flow. So are they going this way or this way? So we need to look up our electrochemical series. So we've got nickel and cadmium. Can you see this here? So 0.4. So sometimes they'll give you something like that and it won't be on here, so you'd have to put it between the ones that are here. But the cadmium is here and the nickel is here. So we've got the nickel and the cadmium. The chemical that is higher on this side is the stronger oxidizing agent. So it's the one that's going to get the electrons and undergo reduction. And the chemical on this side is the one that's going to give up the electrons and undergo oxidation. Okay, so the cadmium is going to undergo oxidation. So whenever you've got something that's going to undergo oxidation, you actually have to write it as an oxidation reaction around the right way, so that the electrons are on this side of the arrow being lost. Okay, and the nickel is gaining them, undergoing reduction and forming nickel metal. Okay, so the question was, which directions are the electrons going? So they're coming from the cadmium, being lost, and going to the nickel. Coming from the cadmium and going to the nickel. So these are the two that are reacting. Give the equation for the half reaction that takes place at the anode. And oil rig cat. The anode is where oxidation happens. Oxidation is the loss. Oxidation is the loss. So the reaction where the electrons are being lost is the cadmium. So it was cadmium metal that lost them. Oxidation is the loss. The electrons have to be over here. It's forming cadmium ions plus. Don't forget that it's 2 electrons. Aqueous. Okay, list 2 factors that need to be considered when selecting appropriate substance for the salt bridge. The salt bridge is used to balance the charge. So if it's balancing charge, then what's in there has to be charged. So you need to list 2 factors, 2 things. So the salt bridge is made of charged ions used to balance the charge of the cell. These ions obviously have to be soluble, because not all ions are soluble, are they? And so not form precipitates. So they can't come over here or over here and react with the cadmium or the nitrate. Not that anything reacts with nitrate. Okay, so these are the same chemicals, cadmium and nickel. It's just in a battery, so it's looking a bit more complex. So it's a rechargeable battery, discharge, recharge. Based on nickel to power mobile phones. Okay, the overall cell reaction for when the cell is discharging is that. So it's looking a little bit more complicated. The cadmium was the one that lost. So some metal is going to lose its electrons and turn into an ion. If you just got this and not the previous question, you could tell that this was CD2+, because hydroxide ions are 1-. So when you cross it over, there's a 1 here, and this is 2, so this would be 2 plus. So the cadmium have gone from an oxidation number of 0 to CD2 plus. So if you had to work it out from here, you can see that the cadmium has oxidized because it's gone from 0 up to 2 plus. It's become more positive, so it's oxidized. If it was being more negative, it would be reduced. So if you haven't done the previous one and you didn't know much about it, you could see that the cadmium has been oxidized. Identify the positive and negative electrodes by using a plus or minus. So you need to know that little table, the anode and the cathode. If it's a galvanic reaction or electrolytic, what charge are they? So that little table. So if you just remember that one, a galvanic spontaneous anode oxidation is a loss, is negative. And then all the rest of them you can work out from that. So galvanic, obviously the cathode must be positive. And then the polarities swap around when it's being recharged. Alright, so the cadmium is losing, there's the cadmium over here, this metal. It's losing the electrons. It's undergoing oxidation is the loss. Where did I put that? I didn't put that on this one. Anode, oxidation is the loss, reduction is the gain. So this is losing electrons to become the ions, losing them, so it's negative. The electrons go around through whatever it's charging, mobile phone, and come in here, and are given to the nickel. So what feature allow it to be recharged? So when it loses the electrons here, the cadmium has lost the electrons and becomes cadmium hydroxide. The electrons have been lost here. If it's going to be recharged, they have to be given back to that cadmium for it to form the metal again. Cadmium can't disappear, so it has to coat the electrode. In this case, it's making a paste. So the products, basically, this has to coat it too, see it's a solid. The products of the, this one has to coat it. The products of the reaction must remain in contact with the electrode. Remain in contact with the electrodes. Give the charge for the half equation that takes place at the negative electrode when the cell is discharging. Okay, so just normal reaction when it's working normally. So negative electrode, negative anode, is the cadmium, so I've lifted too far up, the cadmium. So give the equation for the reaction. So we've got the cadmium losing electrons and becoming cadmium hydroxide. So it's a little bit more complicated than the previous one. You've got cadmium losing its electrons to become cadmium hydroxide. And we know it's 2 plus, so it's lost 2 electrons. And the cadmium hydroxide is a solid because it's coated here. Here it is. Alright, so normally this is a basic fuel cell, so our electrolyte is hydroxide ions, not hydrogen ions. So you can't balance these by adding hydrogen ions. You can't balance the oxygen and the hydrogen. All you've got to play with are hydroxide ions and water. So the easiest thing for this particular one, you've got hydroxide ions over here. In order to balance it, just add hydroxide ions over here. Okay, this negative ion, it's negative on this side at the moment, so just don't forget that your hydroxide ions are negative. Alright, give the equation for the half reaction that takes place at the electrode connected to the negative terminal when it's recharging. So when it's doing the opposite, negative terminal, when it's doing the opposite. So we can see when it's discharging, this is negative. Okay. Oxidation is the loss, oxidation. So we want to, when it's recharging, the cathode, when the electrons are coming back in. Okay, so it's the same electrode. So it's just exactly the same reaction in reverse. Okay. So that's how you use that, exactly the same reaction in reverse. So it's cadmium hydroxide solid plus its 2 electrons back again to make cadmium metal and the 2 hydroxide ions easy.